In the previous video, what we discussed is one of the theorems what we have in differentiability, right? Now, when you have a theorem, there are certain results of it, correct? Now, here we can discuss about one of the corollaries what we have based on the theorem. Okay, we have just one corollary. What that corollary tells us is that every differentiable function is continuous. All right, so this basically what we can say is corollary 1. So what we have is every function, or you can say every differentiable function is continuous. So this is basically the corollary, but the converse is need not be true. Okay, the converse need not be true. That's why only this part of the corollary is true. Okay. Now, anyway, we don't have a proof of how it works and what it works and everything like that. We just have the statement of the corollary. That's all. Okay, but to think about it, I would always recommend you guys to think and solve, come up with the proof by your own. You can take certain examples and do it. Let me give you a hint. You can use the modulus function, to prove it by yourself. Or you can also use the greatest integer function, signum function. You can use these functions to prove that the continuity and the derivative part, both of them need not be like, if it is continuous, it need not be differentiable at that particular point. You can come up with the proof on your own. All right. Now what we'll discuss is we can discuss about the things what you have already learned in differentiation. That is, you have learned about sum, difference, the product, and the quotient, right? So let's summarize whatever you have learned in the last year. Then we'll continue with the same topic what you have this year. All right. What you have learned last year. Suppose if you have two functions u and v. So both u and v are continuous and differentiable functions. I'll just name them as two functions. Easier. Suppose if you have u plus v, then if you are differentiating both of them, then you can write this as u dash plus v dash. Isn't it? Like if you have x square plus x, then you differentiate x square plus derivative of x. Suppose if you have minus, then you have minus. So you can say u plus or minus v whole differentiation is u dash plus or minus v dash. Right? This is the first part. The second is, suppose if you have u into v whole dash, or derivative of u into v. Here we use the product rule, correct? Or we also call this as the Leibniz rule. Leibniz is the one who did lot of things in derivatives. So we call it as the Leibniz rule or the product rule. So here what do we have? We have u dash v plus u v dash. Isn't it? This is basically the product rule, where first you differentiate one function, keep the other one constant, plus keep the first function constant and differentiate the other one. This is what is the product rule. Next we have the quotient rule, which is u divided by v derivative. Of course, v is not equal to 0. Okay, so keep this in mind all the time. This will be equal to u dash v minus u v dash divided by v square. Divided by v square. Now, these are all the things what you have already learned before. Sum, difference, product, and quotient rule, isn't it? Now, what we'll do, we'll look into the next type, or the next type of, you can say, a rule, which will help you in differentiating different types of functions. Now, if you remember, the very first chapter what you have this year is relations and functions, correct? Now, in that, you had composite function, if you remember. We used to write FOG, that is f of g of x and g of f of x, if you remember. Now, we are going to look into composite functions because whatever we had before, they're all very simple functions like take sine x, cos x, x square minus 3x plus 1, something like this. Very simple functions. Where you apply these things, directly you will get the answer. But this year, you have composite functions, something like f of g of x types. So when you have f of g of x types, then you need to understand, okay, how do I differentiate those composite functions? All right. Now, luckily, we have a method, we have a rule called as chain rule. Chain rule helps us in differentiating the composite functions, no matter how composite the function is. In the sense, you need not have just f of x and g of x, like f of g of x. You can have multiple things. You can have f of g of h of a of b of x. Still, you can differentiate with the help of chain rule. All right. Now, let's understand what is chain rule and how we'll apply chain rule in differentiating the composite functions. Now, the chain rule, what you have is, so in chain rule, let's assume that we have some function. Let's say we have f of g of h of x. Three functions are there, f, g, and h, correct? So we need to differentiate this. Let's say this is y. Okay, so y is equal to f of g of h of x. Now, let me give you an example with this. Let's say we have y is equal to sine of cos of, say, x square. Function f is nothing but sine function, g is nothing but cos function, h is nothing but x square function, correct? Square function, basically. So we have the functions. So now what we do here is we always start from the outermost function. Mind you, we start from the outermost function. Okay. So now what you can do, see this g of h of x. Let's call this as some other variable. Some variable. Okay, let's call this as, let's say, k. Now what do we have? We have y is equal to f of k, correct? But what is k? G of h of x. It's a composite function, isn't it? So now what do we do? See, when you differentiate, we can write f dash of k, correct? Into, because k is a composite function, isn't it? When k itself is a composite function, we can't just leave it as it is. We also have to differentiate that one. Make sense? This is basically chain rule. So chain rule is what? You take one function. Inside that, you might have multiple functions. So all the multiple things, you take it as one. Okay. You differentiate the outermost function here. F is being differentiated. Once that is differentiated, you are going to have y dash as f dash of k, where k is nothing but g of h of x. Make sense? So if I am going to do the same thing for this example, what you have, the outermost function is what? Sine. So y dash is equal to, and what is the derivative of sine? It is cosine. So you have cos of x square. That means what have I taken? This cos x square. I've taken it this as k value. Correct? Already inside we have another composite function that we are taking it as k. Okay, well and good. Next, what do? We f dash of k into, we have to differentiate that k. So k dash. Understood? Now, what is k dash? Now we'll calculate what is k dash. So k is nothing but g of h of x, isn't it? Now what we'll do? see this h of x. So call this as some other function. Let's say we'll call this as L, some value L. All right. Now what do we get? K is equal to G of L, isn't it? So what will be K dash? G dash of L into the next one is what? L dash. Correct? Now last part. What is L? L is h of x and L dash becomes h dash of x. Basically derivative. Now what we are going to do? See this K dash, whatever you have, that you'll substitute here. Okay, so you are going to get y dash is f dash of k into g dash of L into L dash, isn't it? Now what is L dash? H dash of x. Substitute. So you are going to get at the end as y dash is equal to f dash of k into g dash of L into h dash of x. Guys, it might look very complicated, but it's not. What are we doing? The logic is very simple. You start from the outermost function, differentiate that. Come one step inner, differentiate that. Come one more step inside, then differentiate that. If you have one more, go inside one more, again differentiate that. So from the outermost to the innermost, you keep differentiating. That's the same thing what we are going to do here. First, what did we do? We differentiated sine, we got cos. Correct? The first part, the outermost function is differentiated. Then after that, what do we do? You go inside. Inside is what? Cos of x square, right? You differentiate the cos function. Like how we differentiated the g function in this part, the mid layer part, isn't it? If you differentiate cos, cos is what? Minus sine, isn't it? Into minus sine of x square. X square. Now, what is the innermost function? Innermost function is x square. That's like saying h of x, isn't it? When you do that, what is the derivative of x square? 2x. So what did we get? Cos of cos x square into minus sin x square into 2x, isn't it? In other words, you can finally write the answer as y dash is equal to minus negative sign 2x, correct, into sine x square, not sine square x, but sine x square into cos of cos x square. This becomes the final answer. So if you look at it, guys, carefully understand. If you want, just go through this video one more time. First, we start from the outermost function. Then we go into the next layer, next layer, next layer. So keep on going. So from the outermost to the innermost, this is the order of the precedence for all chain rule values or chain rule functions. In the next video, we'll look into the more examples of this chain rule, how we'll apply, what results you will get, everything. You'll see this in the next video.